This is going to be a look at what broadband noise looks like. And again, we're using our 8566B spectrum analyzer. And we are going to zoom in on the screen. We have no signal in at this point in time. We have pretty much the same setup as last time. We are starting at 44 megahertz, stopping at 54 megahertz. Our marker's at 49 megahertz, midway in between. Center frequency. That's the frequency our radio was tuned to. And now we're going to take a look at the signal source, which is going to be the impulsive generator we use to listen to broadband noise in the radio demonstration. And here we have it. And you'll see that the amplitude is turned way down. And we are now going to turn the amplitude up all the way. Now we're going back to the spectrum analyzer, and what you can see is that there is a pulse train, if you will, that you can clearly see, but it is not at any particular frequency. I'm going to hit the view button here, which freezes the frame at any point when you push it. And you can see those guys. And I'm going to clear. Here's another. Clear. Here's another. Clear. Here's another. Every time the pulses are at a different place. It's pretty much random. And what's happening here is that these components are basically all over the place, but the spectrum analyzer can only be at one frequency at one time, and so whether or not it records something is when it happens to be at a particular frequency, did the impulse generator fire at that point in time. So basically you have a convolution of the frequency domain sweeping of the spectrum analyzer and the time domain pulsing of the impulse generator, yielding a hit or no hit. Now, a better way to look at this thing, to give you a better feel for it, is we're going to use the max hold function of the spectrum analyzer, which basically holds the maximum level that it records at any frequency until you clear it. When I push that button, we'll start to see the screen fill up. I just pushed it. You can see that the thing's filling up. We're losing all of our low levels, and you can see now that we're capturing the peaks. And what this means is, as you can see, and this is what happened when we were tuning the radio, is that no matter where you would tune a radio in this band, you can't get away from the signal. And that's the inherent nature of a broadband signal. This is exactly opposite to the narrowband signal we were looking at, where unless you were exactly on that frequency, there was nothing to be seen. So this gives you the feel for broadband. I'm going to go back and clear write it. And that is the nature of the broadband signal in direct opposition to the earlier narrowband signal that we looked at. Thank you.